Welcome back. Myself is Nishandar. Please subscribe my channel Siddhanath Nishandar. Today we see the reciprocating compressor. In previous video I discuss the working of single stage compressor. Okay, now we discuss multi-staging or two-stage compressor in today's lecture. Okay, last lecture I discussed what is meant by the positive displacement compressor. Okay, we know that where the pressure is increased by, I have told that you remember the three words. First one is the by engaging or by the squeezing, first one, or by reducing volume, and third one is the backflow of air. We last lecture discussed the single stage compressor. Okay, and also we are told that what is the need of the air cooling, because if the proper cooling is not there, the volumetric efficiency of the compressor going to less, because the volumetric efficiency is, we know that what amount of volume sucked during the suction stroke or the induction stroke, because of the heating in the inlet valve or the intake manifold, the air in the cylinder having increasing its volume. So what amount of air, the mass of air come during each stroke of the induction is less, so it affects on volumetric efficiency. So we need proper cooling, air cooling for the low capacity. Okay, now we see what is meant by two-stage compressor. First draw this diagram, two-stage compressor, then we discuss how it works. Okay, the two-stage compressor means, if you see, there are consist of two cylinder. Okay, according to cylinder we classified single stage or multi-stage. Okay, we see here there is a one cylinder and another cylinder is there, so it is two cylinder, so it is a two-stage compressor. Now tell me, it is a single acting or double acting? I have told that on the one side of the piston there is only one delivery or intake valve is there. Okay, so it is a single acting. In case of double acting, on the both side of the piston there is inlet or delivery valve, inlet valve and delivery valve. But in that case, it is a two-stage and single acting compressor. Okay, now it working. If we see here, the two cylinder, one is the low pressure cylinder, another is the high pressure cylinder. What is the need of now work? What is the need of the two-stage compressor? Instead of performing full compression of air in a single cylinder, okay, it is a compressor successively in two or more cylinder. Okay, rather than compressing, suppose there is a high pressure and that high pressure achieve, rather than single stage, it is carried out on two stage. Now what is the purpose regarding that or behind them, we see today. Okay, air after compressing in one cylinder is cooled in intercooler. You see, air after compressing in one cylinder is cooled in intercooler back to its initial temperature before it enters into the next cylinder. Okay, I again repeat. Suppose during suction stroke, what amount of air inside the cylinder at atmospheric temperature, what it may be. Okay, suppose it 32 degree or 28 degrees Celsius. During compression, increasing its pressure, temperature, and that high pressure, high temperature air is passed to the next cylinder. We call as a high pressure cylinder. Okay, suppose there is a 14 bar is our final pressure. Okay, that final pressure we achieve in two stage. Suppose in first stage we achieve the pressure around 5 bar, and the remaining pressure is we gradually increasing in the high pressure cylinder. Now that 5 bar pressure and something temperature is there, suppose 40 to 45 degrees Celsius, that air temperature is going to the intercooler. Okay, what is the role of intercooler now? In intercooler, the temperature of the air is going to such a way that reduced, such a way that is the final temperature. So the temperature is a T1, after compression in low pressure T2, and in intercooler temperature is after outlet of temperature intercooler is a T3, and we achieve, or our purpose to achieve that temperature of outlet T3 is equal to the temperature at inlet at low pressure cylinder. That is our target. If we achieve that T3 is equal to T1, okay, it is a intake temperature, that is a T3, and T1 is that inlet temperature here, T1. So that if we achieve T3 is equal to T1, it's called the perfect intercooling. Okay, after that temperature, low temperature now enter in that high pressure cylinder. It's again compress and deliver at a required pressure. Such a way that we compress the air in a two stage. We can again repeat. A compressor operating in this way is called as a multi-staging. The two-stage compressor having two cylinders, one low pressure and second is a high pressure cylinder and one intercooler in it. The air to be compressed firstly enter in low pressure cylinder at pressure P1 where it is compressed polytropically to a pressure P2 and is then discharged into the intercooler. In the intercooler, the air is cooled approximately at a constant pressure. Okay, the temperature is such a way that at constant pressure, okay, thus giving it is heat to the cooling medium. It may be air cooled, it may be water is surrounding throughout the intercooler. It is then taken into the high pressure cylinder where it is compressed to the delivery pressure P3 polytropically, and finally the air is then delivered to a receiver at a constant pressure. Okay, if we see the arrangement, now we see the working of two-stage compressor or indicated diagram for on a PV diagram. Okay, I will again repeat. Suppose it's a single cylinder, low pressure cylinder, and this is the compression process high pressure cylinder. If you observe, generally they ask the competitive exam, what is the size of the compressor? Okay, now tell me what is the size of the compressor in case of medium or large. If you observe, both cylinder size is not same. Okay, they ask in oral exam also which size of the compressor is small or which size of the compressor is large. If we some of the students, they're confused, they told high pressure cylinder size is large as compared to low pressure, but it's wrong. In low pressure cylinder, initially the volume of air come, okay, at below the atmosphere pressure. When the piston moves from TDC to BDC, the initial the volume come having a large volume. Okay, so initial low pressure cylinder having volume is large, size of the cylinder is large as compared to the high pressure, and after compression we going to compress the air, so there no need to large cylinder volume in case of high pressure cylinder. Initial volume of the air is large, so in low pressure cylinder size is more as compared to the high pressure cylinder. Okay, now we see the working on a PV diagram, how it works. Okay, initially when piston moves from TDC to BDC, volume of the air sucked, that is, if you see I have combined diagram, initial at pressure P1 volume is sucked in low pressure cylinder, it compressed. Okay, P1 to 1 is suction of air low pressure cylinder at constant pressure, and 1 to 2 dash is the polytropic compression of air in low pressure cylinder. I told that we have tried to achieve the polytropic compression near to the isothermal and lies between the isentropic and isothermal. Our try to achieve polytropic compression. Okay, 1 to 2 dash, if you see 1 to 2 dash here. One to 2 dash, the polytropic compression low pressure cylinder. Now his operation very important. 2 dash, here see 2 dash to P2, delivery of compressed air from low pressure cylinder at constant pressure P2. Okay, you see it is the low pressure cylinder working here. Now that discharge compressor air P2, okay, taken pen here, that discharge pressure P2 at constant pressure is a cooling process. What amount of temperature is supplied to that intercooler, that temperature going to reduce at constant pressure. So in intercooler the pressure remains constant, so P2 is there and P2 is there. Okay, so 2 dash to P2, delivery of compressed air from low pressure cylinder at constant pressure P2. So what amount of pressure is actually at low pressure cylinder outlet, that same pressure the intercooling process is going on where temperature going to reduce. Simultaneously as we reducing a temperature, what happens? So volume must be reduced. It's very important. That is the main role of that intercooler. The volume is also going to reduce. So there is no need to the high pressure side compressor is large. Okay, if you anyone ask in the competitive exam, in oral exam, there's the main reason told the after intercooler the temperature going to reduce, so simultaneously volume is also reduced. So for accommodating that air, we need the low capacity size of the volume cylinder. After 2 dash to P2, okay, it is delivered then P2 to 2 suction of air to high pressure cylinder at constant pressure P2. Okay, P2 to 2. Okay, now see here 2 dash to P2 that supply the some volume air. 2 dash to P2 is supplying the air that to the intercooler, and during it pass to the high pressure cylinder, is volume is now P2 to 2. So it is the volume is going to reduce. So see here P2 to 2. I mention here P2 to 2. The suction of air to high pressure cylinder at constant pressure P2. 2 to 3 now. If you see here 2 to 3 polytropic compression of air in high pressure cylinder, and 3 to P3 the delivery of air from high pressure at constant pressure P3 to receiver. After the high compression we achieve pressure P3, okay, and then discharge to the receiver. If we go through this slide again, understood what are the process step by step. Now then we discuss the note on them. Okay, now see, if we carried out the compression single stage rather than two stage, here your compression carried on two stage in low pressure, high pressure, and the combined the PV diagram is there. If you carried out the compression in a single stage, what happened then? If you observe, if you compression is carried out in single cylinder, okay, then what happened? I am highlighting the area yellow. If your compression is carried on single stage, and if your compression is carried out in a two stage, the area is that marking, red marking here. Okay, then what we change, observe the hatching area is what it indicates. The saving in work is very important. If you carried out the compression in two stage, but important condition is that the two cylinder is provided with intercooler, then and then it possible to saving in a work. Okay, so it's a very important term they ask in a very exams. In two stage compressor, why need less work as compared to the single stage? So it is the reason behind them. We provide the two cylinder with the intercooler. Okay, now note we discuss here. Perfect intercooling, I have told that perfect intercooling means what? I will told that if T1 is equal to T3, that is called a perfect intercooling. And if perfect intercooling is happen, then what happen? The point number 2, the point number 2 is lies or overlap for the isothermal process. If you compression carried out isothermally, for perfect intercooling, the point 2 number is lies over the isothermal compression. But you know that the isothermal is the hypothetical ideal process. Perfect intercooling two stage compressor. Perfect intercooling means that after the initial compression low pressure cylinder with its temperature rise, the air is cooled in an intercooler back to its original temperature. That is, if T2 is the temperature after compression and in low pressure cylinder, and T1 is the suction or original temperature to low pressure cylinder, for perfect intercooling I told that T2 is equal to T1. Okay, in case of perfect intercooling, pressure ratio per stage is equal to, that is in two stage compression, P2 upon P1 is the pressure ratio is constant. In multi-stage, P2 upon P1 is equal to P3 upon P2. When cooling is perfect, point 2 will be an isothermal curve. I told that. Now multi-staging. What is the role of multi-staging? If high pressure is air is to be delivered by single stage compressor, it will be required heavy working parts in order to accommodate high pressure ratio. This will increase the balancing problem, and the high torque fluctuation will require a heavy flywheel. If the whole compression carried in single stage, I have told what are the disadvantage. We need heavy construction, heavy flywheel, fluctuation problem, vibration problem. So that whole problem is avoided in two stage, as well as we need or we require less amount of work. So multi-stage is very important. Advantages, I now summarize this lecture. Advantages, the power required to drive multi-stage compressor is less. Multi-stage compressor has a better mechanical balance. Pressure range due to multi-staging remains within a desirable limit. So losses due to air leakage are required, less required. Temperature range due to multi-staging remains within the desirable limits. Due to multi-staging, volumetric efficiency for given pressure ratio improves. Okay, thank you.